I'm Troy Demmer, co-founder and president of Gecko, and I'm joined by my longtime friend for nearly a decade and one of our founding engineers, Ed Briner. We are excited to present to you today Gecko's product suite. We have heard from many of our officers quote Mr. Donald Rumsfeld, "You go to war with the military you have, not the one you want to build." But our equipment is nearing the end of useful life, and we can't build fast enough to keep pace with our adversaries. Our armed forces need their assets and platforms operationally ready. However, schedule overruns, growing maintenance backlogs, and our antiquated maritime industrial base are crippling our fleet's operational availability. We need more platforms, and we need more capacity. Building new assets faster is not the only problem we must solve. We must maintain what we have better. Right now, we have over 100 ships waiting for a maintenance cycle, despite spending 60% of our Navy's $26 billion in O&M budget on maintenance alone. We are historically paying way more for way less capacity. We need a better process. We need to move fast and fix things. Let me introduce Joe. This is Joe. He frequently does the critical work to diagnose the health of the built world. Not just from an understanding of the data, but welding, inspecting, and maintaining. Joe is how critical asset data is collected on hundreds of millions of dollars and billion-dollar platforms today, using handheld sensors at risky and elevated heights. This at best ends up creating a PDF report or a handwritten log that is the basis for our repair and replace decisions, sometimes costing in the order of tens of billions or hundreds of billions of dollars. Joe is also the skilled workforce that we are struggling to hire and retain across our defense industrial base. Now here's an example of that data output. As you can see, it's low fidelity data, sometimes pretty actionable. But as you can imagine, this data is not consumable by software. It's not leveraged within the enterprise. In order to create the digital twins and the digital thread between those with purchasing authority and those who build, maintain, and modernize our fleets, we need to have a foundationally different approach. And this is what drove me to build Gecko. So you see, we have robots that fly, walk, climb, swim. We have sensors that we put on those modalities to help us to build out the data sets to help us manage our most critical infrastructure. We digitally encode and localize these data sets to help drive important outcomes for how we build, maintain, and operate our most critical platforms. And with this, I'm going to turn it over to Ed to dive into some of these use cases.
Thanks, Troy. Our digital twin platform is built on the ground truth from first principles. We aren't building software on top of human transcribed PDF reports. We're starting at the foundation of how our assets' health data should have been generated and organized and leveraged, from atoms to bits, and then from analysis to decision. This is Cantilever, our operating platform of the built world. Today, I'm going to take you through 3 notional demos of our Cantilever platform. First, we'll start in our maritime industrial base, where a nuclear submarine assembly is being built, where our platform is deployed and optimizing the workflows performed by a network of sensorized heavy machinery and industrial robots. Here, at our industrial base manufacturer, this facility has been tasked to build our next generation submarine. The problem here is that the program needs to build these nuclear assemblies in 50% of the fastest end-to-end delivery date thus far, 7.5-year assembly cycle. This assembly requires a full volumetric through-body scan of our forged and welded components to ensure it can withstand the unique extreme operational pressure of a submarine. A typical bottleneck where Joe and his team are tied up for 3 to 4 weeks per subassembly performing these handheld inspections, whether they are ultrasonic or radiographic. This same scan is now accomplished using our platform in a single 12-hour shift, and anyone in the program can review the progress and audit the data in an ATO cloud environment. Further, we can perform a dimensional analysis and a final nick and ding inspection simultaneously with the photogrammetric and laser scans from the system. Next, the prime integrators can use the same sensorized system and the digital twin to interrogate the weld quality. Here, we're inspecting and 3D visualizing the volumetric scan of a multi-layer double V weld using phased array technologies. This allows us to automate the inspection and to do the analysis and flaw detection, sizing, and characterization of the flaws found. In the same digital twin in Cantilever, Joe can review the automated inspection indication table, add his own labels and findings, and ultimately take action on the part, taking that corrective action to re-weld and grind out those flaws. Next slide. We've proven a 95 times savings compared to the traditional human paper-driven workflows for this process alone in the program. This digital snapshot is also the birth of the asset's lifecycle digital twin, now a natural byproduct of the manufacturing process, but also the foundation for future lifecycle maintenance and extension programs. The second demo I'm going to take you through in the Cantilever platform is on the maintenance of our surface fleet. Our TICOMs and port engineers have the incredibly difficult responsibility of balancing the work and availability packages that go on in dry dock. It's been well documented that we're suffering from unpredictable growth work, costing us 3 to 5x in surcharges and sacrificed operational capability with ships, sitting and waiting. Today, we are demoing a solution to build a model of the ship with many health data layers, from ultrasound to visual imagery, at resolutions never before seen, enabled through robotics and AI. Typically, Joe would get just a couple thousand ultrasound readings and a visual inspection transcribed into a PDF report. Now, we continuously scan the entire asset, collecting tens of millions of data points, creating true intelligence about the material state of the ship. From there, we can build a workflow for port engineers. In this example, we're building a repair plan for the hull, factoring in critical condition, schedule, cost factors. All of these ultimately optimized for a final work order that can then be pushed into our enterprise. We also use predictive corrosion models to project the future state of this asset. Over time, as we began to deliver this product, we became aware that what really saves the Navy time and money is knowing the material state 365 days before the ship pulls into dry dock. And for that reason, we've integrated our solutions onto partner submersibles to go underwater. And we've integrated new sensor stacks to be able to read through the non-skid on flight decks. Ultimately, this has allowed us to affect the availability package pier side 365 days before we need to pull this ship into dry dock. On the USS Higgins, we've saved the Navy from the original overwork plan of replacing an entire flight deck, conservatively a $7.9 million affair, and 6 months of human workdays saved with this technology. Finally, we'll move into our newest demo, where our solutions are helping to modernize C-130s. Here, we're using drones to photograph the exterior of a US Air Force aircraft. In this case, an AC-130 gunship. Once again, we're using robotics and software to separate the data collection and analysis. The drone operator collects the data, and in this case, moves it into Cantilever in a rich asset model. In just a few keystrokes, I can actually cycle through a couple other historical scans on our platform. In this case, a tail that had previously been collected at a really high resolution while the asset was in a hangar. Cantilever allows Joe to click on this model and be able to visualize all of the OQE related to this asset, instead of scanning through this asset in an inefficient alphanumeric serialized folder structure. This is saving Joe and the team hundreds of engineering hours. Let's cycle back to the original scan. To help our visual inspectors, we've also developed a segmentation feature, allowing inspectors to open and close segments to do regional-based inspection, scheduling, and auditing. You'll see here we've actually automated and identified a couple coding failures in 2 areas on the wing. And we can audit and verify those indications. Next, we'll move over to a new area for the inspection. We'll move over to an area that hasn't been looked at and audited yet. Our subject matter expert is able to inspect, observe, and ultimately label a corroded fastener failure. And this is sufficient data to be able to create and apply a new indication for our CV integration and interrogation model. Cantilever can take that insight, interrogate the digital twins of the entire fleet, and immediately identify other assets that are having this same core condition failure. Then we can begin the remediation and ultimately update our budget planning. A modification and modernization team that's deploying this technology at an Air Force prime projects that we can save them several engineering months with this workflow alone. So we showed you 3 different examples across build, maintain, and modernize. But compounding leverage will come from each asset going through these stages. As a digital twin is updated through its life cycle, it will be treated as if it's part of the asset, part of the physical whole, the physical wings, the engines, the weapon systems. These digital twins start to compound in value and increase in utility as they are created at asset birth, updated, scaled, and throughout the maintenance cycles, leveraged for design, safety improvements to give us real confidence for our future build, maintenance, modernization, and lifecycle extension programs. With that, we thank you.